All right, thanks, Amir. So welcome everyone to the second session of the series. So I'll be talking a little bit about deploying large language models in your own environment. I'll be covering a number of different topics. I guess a little bit of background about myself. So I currently lead the machine learning team at VoiceFlow, which is a conversational AI company. We recently just launched our AI Playground feature, which lets you do some fun conversational design with GPT-4. So I won't talk too much about what we're building. I'll talk about mainly LLMs in your environment. So let's get started. So I was chatting with Amir about this. He's like, what are you going to demo? And this was April 11th. And what day is it today? The 28th. And my response is, we'll see in 2 weeks, right? We'll see what comes out. And the reason I put this in this slide is that a lot of cool stuff has come out since. There was Open Assistant got released. So that was a project going on, I think, for the past 6 months for training or collecting a data set and then fine-tuning a large language model to be similar to ChatGPT. We had Red Pajama, which is a massive data set that was released to try to replicate Llama's training data set. We also had Stable LM came out as well. And I left this top left corner open because I thought something might come out yesterday or this morning, but we'll see. So a lot of very substantial things came out, both on the dataset side, on the modeling side, and even on papers. I didn't even include new papers in here, but a lot of cool stuff. So talking about this question, I think there's a little bit of discussion before I joined, but what is a large language model, right? So I'll give a question to the group. Is BERT a large language model? If anybody wants to type that into the chat here. No. Okay. No. Oh, got a yes. Yes. Okay. So some controversy in here. Okay. Next question. Is FLAN T5 a large language model? Yes, kind of. Large in the name. You're right, Amir. Okay. What about FLAN T5 XXL? Is that a large language model? Okay. So we're starting to get into some interesting questions. So for the purpose of this talk, I'm going to define a large language model as any general purpose model that does better than the original GPT-3. That's going to be my definition. I haven't seen that definition before. Maybe maybe it has been out there, but that's the definition that I've used. So it's kind of interesting if you go through the benchmarks. We have GPT. Where do we have it? GPT-3 is ranked 35 on the MMLU benchmark dataset. And then we see here on the left, we see FLAN T5XL doing well. We see Llama. We see even bigger Llama. We see FLAN XXL. And we get all the way up to GPT-4, which kind of destroys the competition. So basically in here, going up from GPT-3, original GPT-3 175 with no fine-tuning, everything up from here in my eyes is a large language model. Now this is pretty controversial because OPT and Bloom aren't on here, so apologies for fans of those models. But for my definition, just for this talk, these are all large language models. So under that definition, FLAN T5 large is a large language model because it can do the tasks in this benchmark to a performance higher than GPT-3, even though it's only 780 million parameters. Llama 13 billion is up there, FLAN T5XL, XXL, and so forth. So these are our large language models, and the open source ones, we have 3 FLANs and 3 Llamas, I think. So I might have missed some models, but this is what I have as part of the definition. Now, Llama has a restrictive license, so it can't be used commercially. So if you want to use an open source large language model in prod, you're stuck with FLAN. If you care about MMLU performance or some of the other benchmarks. Okay, so I've started off this talk with some controversy. Let's keep going. So we know we can deploy FLAN T5 XXL in our own environment due to open source licensing and performance reasons, but why would you do it yourself? So one reason might be compliance and data localization. So my past job, I was working at a bank, and one of the requirements for a lot of banking data in the cloud was that it had to be within a Canadian data center. So this was actually interesting when companies or cloud vendors are trying to enter a market. It's something important to consider. So if you want to get a Canadian banking client, for example, as a cloud provider, you need to have a Canadian region. And usually you want to have more than just one region. You want to have two regions because you want to do disaster recovery. So if you're a bank in Canada, you need to deploy your large language model either in a cloud Canadian data center or your own data center. Similarly, for US tax data or any data originating from Germany, those each have to be in their respective countries. So this is something to think about, is that when you go to OpenAI's API or Anthropic's or any other vendor, they don't actually tell you which region that it's in. You can infer that it's probably in US West or US East, but you don't actually know. So this is something important to think about, is as a business, are you fulfilling all your requirements? The second thing I think to think about is your data moat. So what's interesting is that these large language models have been trained on a collection of data, right? We know roughly what Llama was trained on based on the paper. The Red Pajama data set that was open source tried to match that Llama data set. But you can see here we're missing any domain-specific data, right? So if you're an organization that has domain-specific needs, and we know that models that are fine-tuned on specific tasks still do better than large language models, you want to keep your own data because it is your strategic advantage, right? So here I've listed 7 types of data that would be advantageous if you didn't send it to another provider, right, for model training, because there's a risk of that data leaking, right? Sometimes it is based on contractual obligations. Sometimes it's based on mistakes, right? So ChatGPT and Samsung had an encounter where Samsung employees posted confidential, I think it was patent information or design information, into ChatGPT, and that information was used for training. Now, ChatGPT and OpenAI have released a ChatGPT for business use case, which you pay them more money so that they don't use your training data. But this becomes a question of how much do you value your own data? Is a contractual obligation enough, or do you want to keep it within your own environment? So something to consider, especially since large language models are generally trained on very, very general data. And when you have your own data, your models perform better. So then we get into cost, right? So I listed 4 types of costs here. So the first one is training cost. So to train a large language model, it costs a lot of money. I think Mosaic posted in 2022 that it costs around $500K to train your own GPT-3 equivalent model from scratch. You probably wouldn't be doing that. You'd probably be doing some kind of fine tuning. But if you wanted to train something yourself, it would be expensive. And you can compare that to something like fine-tuning an OpenAI model, for example, fine-tuning their 13 billion parameter query model. It's still fairly expensive. You're charged by the token. And if you're doing continuous fine-tuning, that stacks up. So you're making a trade-off between GPU cost and sort of using it as a service. Likewise, there's inference costs. You're charged by the token for existing models, right? GPT-4 is fairly expensive if you use the full context length. So that's something important. If you're hitting a large language model 1 million times a day, those costs really add up. On the other hand, you can treat it as a serverless service where if you only have a couple of users using it, you don't have to worry about it. Just eat the couple of cents everyday cost. Now, the other interesting cost is for use cases where you're doing semantic search or any kind of retrieval task is that you actually have to embed your documents. So depending on how often your data drifts or needs to be updated, there's also embedding costs. Personally at VoiceFlow, we've looked into this, and it's quite expensive actually to use an OpenAI embedder or a Cohere embedder as compared to running your own model, depending how often you do an update. So I think Cohere released a blog post yesterday about embedding all of Wikipedia for, I think it was $50,000. So that's a pretty good ratio. But if you're continuously doing updates on your data, let's say you have like a knowledge-based system with 100 gigabytes, you're updating that every day, you're going to hit that cost very quickly with third-party APIs. Plus, you can't parallelize things as easily too. And then the final thing, and I think something that data scientists and ML engineers typically don't think too much about, is network cost. So the way cloud providers get you is that they charge you for taking data out of their region. So putting data in is free, but moving it out costs a lot of money. So if you're moving data from a data center or from a cloud environment, those charges add up. So if you ever tell a cloud engineer ingress or egress costs, they might shudder a little bit. You might activate some bad memories. So this is especially important depending on your training size or inference size even, because the going mantra is to keep your data close to your compute. And if you're using a third-party service, it's really hard to do that. Now, the counterfactual is that what happens if you host, you have a dedicated large language model, like the Foundry offering by OpenAI. What if you have that deployed, but you have your own instance? That's also really expensive. So it's no longer serverless. So you lose some of the cost benefits, but it might be cheaper if you're continuously hitting it with training requirements or inference requirements. Okay. And with that being said, costs aren't just monetary costs. They're uptime costs and latency costs. So here's an uptime chart for OpenAI in the past 3 months. You can see here they've had some bad days, but if anybody's deployed services, then all of us have had these bad days where production goes down and you have a rough day. But what's interesting here is that these numbers look pretty decent as SLAs. They're almost 3 nines of reliability for April. But what story isn't told here is the latency. So when we've been integrating with OpenAI, there are times if you're using the regular API as opposed to a dedicated instance where you'll just have really bad latency and your HTTP calls will time out, right? So something else to consider is, are you running into a noisy neighbor problem? Do you need to go ahead and pay the, what is it here, hundreds of thousands or millions of dollars to get your own dedicated instance, whether on Foundry or on Azure, right? Because otherwise you might have theoretical uptime, but it takes like 30 seconds to get a request back. Okay, we have questions there. I'll answer those towards the end. Now, the other thing to think about is vendor trust, right? So the question is, why are you deploying in your own environment? Because the big tech companies, the big ML companies that are doing this will probably do it better than you, right? So is it a cost reason? Is it a trust reason? Why are you doing this, right? And a lot of the reasons have to do with trust, right? So if we look at the cloud vendors here, we can look at, for example, AWS. One of the things that a lot of retail companies do is that they ban the use of AWS because Amazon as a company is competitive with them, right? So there is, they don't want to funnel money through AWS into Amazon because you're dealing with a competitor. Other vendors, cloud vendors might have other questions, right? So Google has come under fire for shutting down products early. and such. Microsoft has had their own controversies as well. So there's a bunch of opinions that you and I probably have about each of these vendors, but this is a lot of the time how people make decisions, right? Is based on the vendor that they trust. Are they a trusted technology partner? What projects have they delivered in the past, and so forth. So here I've listed a number of different companies, and if you're thinking about what qualifies as your own environment versus a cloud environment, right? You all will probably have a different opinion. I included Shady Co at the bottom, right? Because if there's a random startup that gets deployed and they have a shady legal agreement or not a good reputation, you probably won't use their environment to deploy, right? But you might trust setting up your own, let's say, AWS account or Azure account or a GCP account for training on one of their managed services or connecting to your own applications. The other thing is that a lot of organizations care about certifications for compliance and regulatory reasons. So here are three that are mentioned. I pulled this graphic from Vanta just because they had all three of the logos here. So SOC 2, HIPAA, and ISO 27001 are pretty standard certifications. So this is something that a lot of people look at for security and compliance and say, does this vendor support this certification? Because it means that they have some underlying principles that they follow. So the big guys typically have all of them, right? It's something that they brag about. If you're a startup, then getting these certifications is tougher because there are processes you have to go through. So this is also a decision that you have to make as both a consumer and a producer of ML services, is what's important to you in decision making. Okay, network security. So in a past life, I worked in the cloud space as an infrastructure architect and engineer. So one of the reasons that people care about deploying LLMs in your own network is that, or in your own environment, is the network security component. So if you've worked with cloud infrastructure, you might know about private endpoints or private connections, where you basically don't send traffic over the public internet. You do it through the cloud provider's backbone, meaning that there is some guarantee or theoretical guarantee based on how data is being sent on the backbone that it's more secure. You can limit who can access the data, similar to how some of you for work might need to use a VPN to log in. But it's basically a direct path between some of your services. Now, some vendors offer the ability to connect over these private connections. So here I pulled up a diagram from Snowflake, allowing you to connect from your customer Snowflake account, if you're using the Snowflake VPC offering, to your personal AWS account. And then you can use AWS Direct Connect to connect to your on-premise network. So some of the larger vendors do support this private link or private connection pattern for organizations that care about this kind of network security. So this network security typically is more old school. You might have heard about zero trust security, which doesn't care too much about IP addresses or private networks. So depending which phase of the organizational sort of security development you're in, you might opt for different patterns. But at enterprises, banks, telecos, you name it, a lot of these network security patterns are still considered to be a primary type of defense. So this is where, when you deploy your own large language model in your own VPC or connected VPC, this becomes an important consideration. Okay, next type of security, IAM security. So IAM stands for Identity and Access Management. So what this means is that you can only access a service if you can prove that you are who you say you are. So when you log into, let's say, openai.com, right, you can use your Gmail or your username and password, and you're proving that, let's say, you're Dennis from VoiceFlow. Now, the struggle is you might have many of these usernames and passwords in many accounts. So from an enterprise management perspective, that becomes really, really tricky to deal with. So the nice thing of deploying LLMs in your own environment is that you can follow your standard IAM practices. So for example, if you have a cloud environment, you can use existing cloud identities to connect your LLM to a database or other applications without having to set up things like API keys or other things here. So on the left-hand side is a quick diagram from Google about how you can use their IAM policies to connect applications with databases. You can think about the equivalent for LLMs and data stores, feature stores, all those fun things that we care about in an ML ops world. So if you're deploying in your own environment, you have a lot more control on the IAM side of it as well. Now, there's also the user access side. So I brought up the use of ChatGPT or OpenAI if you log in and make an organizational account. So if your company has, let's say, 30 or 50 or 100 different services that they use, SaaS or anything else, right? You somehow need to manage who has access to everything. And this very quickly becomes a challenge. So when people are logging in, and let's say I have access to 10 different databases or accounts or services, and Amir has access to 20 other ones, some kind of admin needs to be able to keep track of that, whether it's our manager or somebody else, right? So in this case, when you're deploying in your own environment, there are a number of different solutions to synchronize these access patterns. So the worst thing you can do is grant somebody access to, for example, your OpenAI account, but not grant them access to your data account, right? And they can't even do anything useful. But then when people leave a company or change roles, right, you might just forget to update the permissions. And that's often how security compromises happen. So very important to have good IAM permissions. It limits social engineering, makes sure that people have access to what they need. But it's hard to do when it's not in your own environment. So there are a lot of cool solutions in place. This can be its own talk completely, but things like using the SCIM protocol to synchronize permissions and groups can be used. Okay, more infrastructure stuff. So this is probably a surprise to all of you. You come for an LLM talk, but you get caught up in a cloud computing lesson. So the other question is, what actually counts as being in your own environment? So some of you might have seen this diagram before. It compares the different forms of cloud and infrastructure, so ranging from on-prem to SaaS. And what it's showing here is that depending on the type of application you use or the type of service, you're responsible for different things. So on premises, you're responsible for everything, right? From building a data center to setting up hard drives and servers and everything else. When you're using VMs, for example, IaaS, you expect that if you click a button or provision some hardware, it'll just show up as a VM for you, right? And as we go further right, more and more things are taken care for you. So I think OpenAI would qualify as a PaaS, just by this definition, where you'd have to provide your own data and sort of your application is a little bit blurred. We get into some interesting territory there. So the question is, when you say LLM in your own environment, do you mean in your own virtualized environment, in your own data center, in your own country, right? So all these things start making, you start asking deeper questions, right? Because own environment is a nebulous term. Now, if we assume own environment means in your own cloud environment, then that gets a little bit easier because there are certainly services and platforms that let you do that. So one of the interesting things that Databricks does is that rather than fully abstracting Databricks, you also have an option to deploy it in your own cloud environment. So you can deploy it within your own VPC or your own cloud account, and it'll spin up the storage accounts, the VMs, and everything you need to power Databricks, but you still get the nice Databricks interface. So this is a very tough thing to do as a company, as a provider, because now you have to be able to deal with cross-account boundaries and dealing with these kind of challenges of, well, what if the customer's account is set up in a different way than my own, right? So definitely challenges here, but there are options if you're looking to deploy some of these large and complicated and powerful services within your own environment. There's also a lot of applications that you can deploy on premises. So on-prem, there's like giant boxes you can buy for ML reasons or other things or server applications. for those who have been in the IT industry for, call it 10 plus 20 years, right? That's typically how deployments and infrastructure and applications would be managed, right? You'd get some kind of program, right? You'd install it on the server, right? And then there you go. There is no cloud applications in the same context that we have now. So if we go back to the idea, I think I flipped my slides here, of IAM security, let's go through an actual example. So if you go to the OpenAI website, you can get an API key. But once you have that API key, you can go crazy, right? You can call any kind of training, fine-tuning code. You can do as much inference as you want because there is no fine-grained permissions on their API keys. I think that's something that OpenAI will fix soon, or hopefully will fix, but that is currently not a policy that they have. So you as an organization, and probably if you're in a big company, security will care about this. If you're at a startup, then it's probably your responsibility to care about this, is how are you going to protect that API key and make sure that if it gets compromised, it doesn't bankrupt your whole account or get you banned as well, right? So recently, OpenAI allowed you to name your API keys, which is great, because then you can say, okay, this is a dev API key, this is a staging, and this is a prod one. They have access to the same models still, but at least if something goes bad, you can disable one of them. So in general, for these kinds of things, for IAM security, what you want to care about is the ability to segment across environments. So dev, staging, prod, whatever you have. The ability to give different people and applications different access. So if you just have an API key for your whole S3 bucket, right, that's pretty rough if it gets leaked, right? If you have a public bucket for some data and a private bucket for other data, right, you want to make sure that you access it in different ways. And generally for enterprises, for IAM security, as I was mentioning before, you want to have this concept of a single pane of glass that you can see, like, where are all your permissions, who has access to what, right? What kind of, what is the traffic for each of these requests? Because as you scale, it becomes very difficult to keep track, and people forget, right? So you need automation and all the standard alerts and monitoring to make sure you do a good job. Okay, people have been asking questions. I have one question for you. Is GPT-4 on Azure in your environment? Let's say if it's launched within your own account. In Azure, it's called a subscription or tenant. In AWS, might be an account, or it won't work. So if you have a private instance, or if you have the current instance of GPT-4 running on Azure, is that considered your own environment? Question to the group.
I literally just posted the same question in the chat.
Okay. People are saying no, wouldn't say so. So no's from the group, but what's interesting is talking to some enterprises, they consider this to be in their own environment, right? They consider GPT-4 in Azure because they have a dedicated URL to it, or a key to it, that this is in their own environment, right? So it becomes a question of who's asking the questions and who's responding and what kind of security requirements that you have. Yeah, and then the policies that Azure has is quite different than OpenAI. OpenAI, I think in March when they released ChatGPT Turbo, said that they won't be using your data from the API anymore. But that was sort of standard with the Azure offering. But the question is, how true is that contractual obligation? Because we've seen in the past that large companies have violated licenses for things like data collection, for example, with code scraping, for using non-permissive licenses. So it becomes a question of how strong is that contractual obligation. Now, the other question is, we've known all of these things. We went through these different requirements and benefits, but how well can you actually set up this process, right, within your own environment, right? So can you set up the IAM considerations? Can you set up the security? So can you actually benefit from all these things you can do, but will you actually do them? The answer is probably no. You have to have a very mature practice to do so. So even though in theory LLMs might be better for certain cases in your own environment, in practice, you might just be giving yourself a lot more heartache and work. And the other question is that you're like, okay, I want to put LLMs in my own environment because that's what the enterprises are doing. I think JPMC said that's what they're doing. They're banning access other than certain applications. I've also heard from other enterprises doing something similar. Samsung had the controversy. So in theory, it sounds good, but very few companies have actually figured out how to have a good MLOps practice and scale it. So with large language models, it gets even harder, right? It's not just deploying models you can fit on CPU or GPU, right? You're getting into sort of a snake den of complication. So here's a slide I had from a previous talk, but I still think it's super relevant. Deploying your own models in your own environment or not has a gradient to it, right? So the axes I'm using here is the model self-trained and is it self-hosted, right? Or where does the data come from? So in the bottom left, something like OpenAI is sort of a fully managed solution. You send them data, you get a model back, you can run inference on it. Then you get sort of a combination of are you using your own data or using a pre-trained model? So then you have sort of opposite corners there with something like running an existing model like FLAN-T5 on Hugging Face, or using Databricks to train your own model. Right? So you get this whole spectrum of what you're actually trying to do and which parts of your MLOps or LLMOps process is actually being run in your own environment, right? Because you might not want to fine-tune your own model. You might just want to run inference on it because you care about the data going through inference, but not through training, right? So a lot of questions that you need to ask when it means, what does it mean to deploy your own model? Another slide from a previous talk, but still relevant. So here are some examples of us using both OpenAI and our own custom ML platform, right? So we've at VoiceFlow run into challenges with both. We've used both, so a little bit of perspective there. But when we were building our own ML fine-tuning and training platform for models, not large language models, just language models, by our earlier definition, it's a challenge, right? It's not easy, and we had fairly straightforward use cases to solve. So there are challenges with both for sure, and costs and benefits. But if you want to host LLMs in your own environment, be ready for that can of worms. So as I said, LLM ops is ML ops, but it's harder because latencies are higher, costs are higher, models don't fit on one GPU. Things get harder. Models hallucinate. They can be toxic, right? They can make stuff up. Lot of challenges there. So one interesting post that came out on this topic was Replit shared an architecture diagram and a blog about their own LLM training. So if you're familiar with ML ops or ML training pipelines, this diagram doesn't seem like something too new, but it's good for the community to see and share sort of what goes into this process, right? So you have standard pre-processing, fetching data sets. As I mentioned earlier, very different size of data, right? Like the stack and public repositories and Stack Overflow, right? Those are gigabytes, terabytes of data. You can't just fit it onto a disk, right? You need to do some data partitioning or sort of lazy loading for it. Tokenization becomes hard because now it takes hours, not minutes or seconds to do, right? All these challenges that exist for doing a large language model, but something that is good to see that people are talking about it now rather than being a purely proprietary discussion. Now, a little bit about relevant tech. So some libraries or blog posts, or I don't know how to categorize these things, ways to get started, right? So recently, DeepSpeed Chat came out, which is a framework by Microsoft to do RLHF based on the DeepSpeed framework. So how to make it faster and easier to do so. There's a blog post by Ray about ALPA for getting higher throughput on the JAX library on large clusters of GPUs. Mosaic's been doing a lot of work both for language models and large language models. And then GPT-4All came out for running these kinds of models on your own device or in the cloud using GPT-J or Llama. And then Llama C++, you might have seen some of those demos running like on a Mac where it's super speedy. Also some cool things to see. I'll also talk about a couple of relevant papers here that are useful.
Dennis, is
Yes.
it possible to do full screen because you're showing a lot of images and they're a little small, hard to see?
Oh, sure. I can zoom in on them as well.
Great.
So LoRa, if you've heard about it, is basically a way to do fine tuning on models with a minimum number of parameters. So rather than fine tuning the whole model, you basically attach this adjacent set of matrices or layers that helps you better fine tune the model by using the inputs and outputs or using the inputs, passing it through this new set of layers and combining it at the end. So this is super useful because you can get really good performance without needing a whole bunch of resources. So this little screenshot is about how you can use LoRa to fine tune models that would your A100 80 gigabyte one. That's a pretty hefty machine. So you can fine tune and actually get a pretty powerful artifact that's fairly small. The nice thing is that this has come into attention a lot more recently because Hugging Face has released packages for this, both for language models and for diffusion models on how to use LoRa in an easy way. So that's been very helpful to make this mainstream from a package perspective. So here's a use case that Phil Schmidt, he writes a lot of great stuff about sort of, I don't know what to call it, ML performance, ML optimizations, papers on this issue. So fine-tuning a FLAN T5 XXL, which we have classified to be a large language model, you can get a performance improvement and only have a tiny 84 megabyte checkpoint to use along with that. So rather than needing to save that 11 gigabyte fine-tuned model separately, you just save this small artifact and attach it to your model at runtime. Another interesting thing from last year that we had was stable 8-bit inference. So this was really important because you can now fit large language models on smaller hardware. So you can see here if you're running a standard mixed precision or 18-bit inference, right? Before you would need sort of pretty massive clusters to run like a 175 billion parameter model. But now you can, on Colab, you can run an 11 billion parameter model, which is pretty cool with 8-bit inference. So this is pretty interesting looking at the underlying sort of kernel operations and matrix operations. How can you actually train and use inference for models that are smaller so that it's easier to run them? Another reason that this is important is that as hardware advances, you can see here the FP8 and int8 performance for a lot of the newer models. You just have a lot more throughput and power here, right? So if you look at like a 32 floating point computation, right, you get 156 teraflops, but here you're getting, in the new generation for int8, you're getting 2000, right? So what is that? At least 10x, like 13x if my math is okay, right? So you're getting quite a strong improvement here where you can actually leverage hardware in a more efficient way. So if you're deploying your own models, 8-bit inference makes it a lot easier to do so. And then we get into crazy 4-bit inference. So this is a paper that came out, I think, late last year, end of 2022, but you could actually use 4-bit or 3-bit precision to get pretty good results on models. And for reference, 4 bits is between 0 and 15. So I don't know how these model weights are actually working. It's kind of mind-blowing to see that you can still get great performance. Like if you're looking here at, let's say, the OPT model, right, that you can get with 4-bit precision, right, you can basically get the equivalent of 8 or 16-bit. I don't know actually how they got higher accuracy. Oh, this is a comparison of total model bits because of the compression. But you're getting pretty impressive results, which is really cool. When if you ask somebody like how you could do this with so little bandwidth, they'd be very impressed. So I guess the point of these papers is that we're going in a very good direction where models are getting easier to manage and deploy. LLM ops is becoming closer to ML ops just based on our advancements in hardware and libraries and understanding of the environment. So quick demo. I know we're running out of time. There's questions. I got disconnected. But here's a cool notebook for running T5. It's not Flan T5, but that one hasn't been properly sharded yet, in an int8 environment where you can run these models, both 11 billion parameters and 3 billion parameters, on a Colab with a T4 GPU. So this is pretty impressive. Once Flan T5 gets properly sharded, or if you're willing to do that yourself, you can run a large language model on a T4 or in Colab, dump it into production, impress everybody you know. Don't do that. Do proper MLOps deployments. But it's pretty impressive that we can use this kind of technology and get pretty powerful models on fairly easy to access hardware.